In this video tutorial, I'll discuss the solutions to the challenges of week 3. But before doing that, I would like to advise you to have another look at Mark's previous video tutorial, because I had the feeling today with the lecture that most of you would benefit from that. Furthermore, I would like to recommend you that during those video tutorials, you actively follow our tutorials. With that, I'm meaning while you're watching the tutorial, open a second window. In this second window, you can open up MATLAB and actively type along with what we are with the video tutorial. This is much better than passively just listening to the tutorials. In this tutorial, I'm going to do everything from scratch because I want to show you how I deal with those kind of problems step by step. It's hard for me to decide what the exact level is of all of our 120 students. So if this might be a bit slow for you, you can just skip some parts and speed up this playing speed of this video tutorial. All right, before turning into our questions, I want to give you a general kind of strategy of using the for loop for such challenges. So why do we use actually a for loop? Well, if you use a for loop, the only reason to do that is that you're going to define a variable within that for loop, and you're going to update that variable for each iteration you scan through that loop. So let me give an example. Imagine we have a vector. So I'm defining now a standard vector. Actually, I just do it like this. And if I run this line of code, we see in the workspace in the right top, I'll move my screen a bit, appearing the vector, which is a variable. And I specified now two cases with a for loop. Either you update the variable by overriding it, that's this in line 12, or the other one, which I turn back to later, is updating value not by overriding it, but by letting the vector grow. So let's start with the general structure of a for loop. This you should be familiar with by now. This is the general structure. Often I is used for simple iterations because that's a bit more short and to the point, which makes your code relatively neat if you have a lot of lines of code. But just to demonstrate, you can put any variable name here. So for value is vector, and if I simply print that value each iteration and run that value, oops, we can see that it's been iterating through the elements of the vector one by one. So the first element 2 and the second element 3. So as I said, the only useful way of making use of the for loop is to update a variable within the for loop. So in this example, I want to calculate the sum of the vector. Of course, MATLAB has for this type of simple functions already built-in functions. So that's called sum. So sum vector will provide me with the answer 5. But in this case, I want to use this for loop to build my own sum function. So we do that by specifying a variable that we want to update each iteration, which represents the sum. So that variable I'm going to call sum vector. And what I specified in line 14 yet is not very exciting. So sum vector will just become the height of the variable value each iteration, which is 2 and 3. But how can we update it? Well, we're going to override it for each iteration with its previous value. So the insight here is to add this to the code so that it will add the value for each iteration to the factor. So when I'm going to run this, I'll probably receive an error. Yes, unrecognized function or variable, sum factor. And why is that? That is because for the first iteration, it's going to print the first element of this factor 2, and it tries to add that to the sum factor, but the sum factor is not known by MATLAB because you can see in the workspace there is no sum factor, so we first need to define it. So you do that always outside the for loop. Before you start the for loop, you can specify or define your variables you want to update in such a for loop. In this case, it's 0, as the sum starts with 0. And this is basically the general framework when you have to use a for loop in challenges. Almost, if in all cases, if not all cases, you will use this general outline to solve your problem. You specify a for loop. Before you start with the for loop, you specify some starting variables. And inside the for loop, you're going to update a variable by either overriding it or by letting it grow. Let's see, when I run this, let's check when it worked, whether it works. So I'll go to print a little bit extra information so we can see what's happening inside the for loop. So this is just the value for each iteration. This is the sum factor before I add this value, and this is the value of the sum factor afterwards. So I just ran this. Let's have a look at the output. So when we start this, the value is 2 for the first time. The sum factor is 0 as we defined it in line 13 as the starting value. Then I'm going to add 2 with 0, that makes 2. Then it executed line 17 and we go up again for the next iteration, and we retrieve the next element of a factor, which is in this case 3. And then we print sum factor. And this is the critical point. Sum factor is not equal to 0 anymore because we've been overriding it. We already ran one iteration and then we made sum factor 2. So this time sum factor is 2 instead of 0. Then we go to the next line of code in line 17 and we're going to add the value 3 plus 2, which makes 5, which represents the sum. Yes. All right, and briefly, which we won't be using in the solutions of the challenges I'm discussing now, but this one Mark has been already showing you. Another way of updating a variable within the for loop, instead of overriding it, is by letting your factor grow. And what I mean with that is I'll just demonstrate by running this piece of code. Let me make 3 of it. So we're going to iterate 3 times through this for loop. And each iteration, we're going to add an element to our growing factor. So we're not going to override it. And for each element we're going to add to it, we add 10 to the value of the current iteration. So let me run that, and then we see in the output. So the first time that growing factor has the size of 1, 11 in this case. The second time, this size of the growing factor is 2, and then the third time 3. Yes, all right, so keep this in mind, and we will encounter this general outline in some of the solutions today, defining a start value before the for loop, and then updating a variable within the for loop. All right, question 1a. This solution is already posted by Robert in a video tutorial, so I won't go into the solution of this question, and you can have a look at the tutorial Robert posted. So I already did that, and we're not going to into the details, but the idea was here that we needed to calculate the factorial. And the factorial, I'll use for my examples, the factorial of 3 is basically 3 multiplied by 2 by 1. Must be 6. MATLAB has a built-in function for that. But in this case, not of 6, of 3. In this case, the challenge was to build your own function, which is called myFactorial. That function is defined in the current folder with exactly the same name as the function. And then you can call it, because MATLAB knows where myFactorial is, namely in your current folder. And you can specify the input argument, and we get the output, which is 6. So the challenge in 1b was to do the same using a while loop. So before starting with the while loop, I printed here the logic or the solution of myFactorial. So what we did to solve this question, as Robert has shown you, is that, again, we specify a starting value before we start with the for loop, right? As I explained with the general outline. Then we start iterating over something. And then in this case, we overwrite for each iteration the value of the variable named vector value. Yes? All right. So now we're going to do the same thing for the while loop, and there are multiple solutions to this. I think I'll choose kind of most basic one to give you a good feeling of working with those loops. So let's first specify or set out the general outline of for loop in MATLAB. So while we start with that keyword, and then within the brackets, we should specify while something is true, I keep on looping through my while structure. So as I said, we're going to use exactly the same strategy as in the case of our previous functions, in which we used in a for loop. So again, we're going to update in each iteration. So I just copy and paste the value of the variable named vector value. And as always with these types of loop, I keep on repeating myself. Before we start the loop, we specify a starting variable, and we do that exactly the same as in this assignment. The vector value is equals to 1 here. So we need to specify something here, because MATLAB needs to know what the condition is to go inside the loop or not. So we want to do that a few times, depending on the value of how many iterations you need. So in this example I use here, the number of iterations should be 3, because we want to calculate the factorial in 3 steps. So what you can do is, while my multiplier is smaller than 3, I want to keep on multiplying. That's what basically is stating here. So in line 44, you tell MATLAB, if the value of multiplier is smaller than 4, because not smaller than 3, because we want to do it 3 times, is smaller than 4, I want you to go inside this loop and start to iterate. Then it will add multiplier by the vector value, but you can already see here we didn't define multiplier yet. So again, we need to specify whatever we're using in this for loop also outside the loop. In this case, I'll make the value of multiplier 1, because we go in the reverse direction. We start with the multiplication of 1 here. So we go in the loop because multiplier has a value of 1, which is smaller than 4. We go to line 6, we do our multiplication, and then when it did execute line 46, it goes upwards again, and it's going to check whether multiplier is still smaller than 4, which is in this case always true because we don't update the multiplier. This value will be always 1. In other words, what we defined here is an infinite while loop. This loop will get stuck. It will never stop because we don't update the multiplier value. And there you have the keyword again. Again, we need to update a variable within the for loop, and this time it's the multiplier. Which we can just simply multiplier plus 1. So as you can see in this case, now the first time after we multiply it with the vector value, it will go to line 47 and it will increase the value of multiplier by 1. So after the first multiplication, the multiplier value will be 2. And then we go up to line 45 again. Then MATLAB is going to check whether the value of multiplier is smaller than 4, which is still true because in this case it's 2. It will run line 46 again with the new vector value. And in this case, with the multiplier value of 2, then it goes to line 47. The multiplier value is being increased by 1, which is 3 in this case. It goes up again, checks line 45. Is the value of multiplier still smaller than 4? Yes, indeed, because multiplier is 3. It goes in again, does the same routine. Then it goes up again, but this time multiplier is 4. And this statement is not true anymore, and MATLAB will quit the while loop. So let's run this. I suppress now all the output, which I did not want to do. So I want to run this and show you at the same time the output. So let's have a look at the output of the while loop. First time vector value is 1. That's true, that's the starting value. And then in line 47, multiplier is 2 because we added it here with 1, which is correct. And then the vector value becomes 2. Then we have the multiplier of 3, and 2 by 3 makes 6. And then the multiplier becomes 4 at the end, as I just explained. And then the while loop quits because 4 is not smaller than 4. And indeed, the vector value is 6, which is correct in this case. And so again, we will put this into a function. So we can start a function by clicking on new and click on function. Well, as you know, MATLAB provides you with the general structure of a function, which makes our life a bit easier. The only thing I'm going to do now is copy and paste what I specify here. I put it inside the function. I always use untab to be a bit more clean in my coding, so I can see, okay, this is the stuff that's going inside the function. So let's start with giving the function a name. In this case, I'll call it my while factorial. Let's start saving it. Save. The default is that the function name is exactly the same as the file name, which should be always the case. Okay, it's the default. Do not change this. We only work with one output argument, so we can remove this one. And what's that output argument we want to provide the function with? That's the value vector value. In this case, because we only return one value, the square brackets are not needed, only when we specify multiple output arguments. So I just removed them to not be redundant. And we only have again one input argument. And what is that input argument? Well, we will replace this with n. So that's the value of which you want to calculate the factorial of. So in our example, that was 3. And then we had our while statement, as long as it's smaller than 3 plus 1. So instead of 4, we're going to specify now 1 n plus 1. And just to be sure, I'll put it in round brackets so MATLAB doesn't get confused. And that's my function, so I can just save it now. I'll go back to my challenge. I can remove this. And now there is this function named my file while factorial. And you can see now why it's so crucial that the name is the same as the function, because MATLAB recognizes this file as how it's specified here. So I exactly type that name. Whoops. And I'll get it again of 3 with my previous function, and just to sanity check whether everything works, I'll just also get the value of factorial 8 and see if they provide me with the same results. And indeed, the first time it's 6, and for 8 it's 40,320. Does that align with the built-in function of MATLAB, which is for sure correct? So the factorial of 8 should give me 40,000. Yes, all right. So to sum up this assignment again, for the while loop, let's go to the function a bit. Again, it was crucial here. So this is the strategy you can always use when using this type of loops. We start with specifying, defining some variables before we start with our loop. And then inside that loop, you're probably going to update a variable of interest. And in this case, we updated it by overriding that value for each iteration. Okay, I hope that's a bit clear. Let's go to assignment 2. I'll just take a sip of my water. All right, the rolling dice. Given a bet, determine how many times you have to throw the dice to win. Do this by writing a loop that throws a dice until the bet is won, and then prints the number of throws needed. So the keyword here is, I think, until. When you read words like this, until, up to, or while, as long as, these are all keywords meaning that you have to do something with a while loop. That's the first insight in this assignment. And for the rest, we have to simulate a rolling dice. So let's start with that. How can we simulate a rolling dice? So simulate or rolling dice. Well, then we can think back of a function we have been using in one of the previous challenges of week 2, and that was the function rand integer. If you don't know what that function does or anymore, then check your previous challenge. But what we can do is use this function, and if I only specify one input argument, it will randomly pick an integer between 1 and 6. And that's what we want, right? We want our random dice to only get whole numbers. So not 1.5 or 2.7, but it's always 1, 2, 3. So this is a 6-sided dice. Let's evaluate this line of code. So I ran it, and this time I threw 1. Next time it was 2. Now it's 4, etc. It's 6. So let's call the outcome of our rolling dice throw. So this is our simulated rolling dice. And then the question was basically keep on rolling the dice until a certain value comes up, and then quit rolling the dice. So let's specify our winning value. I'll call it our winning value, and as in the question, I'll just call it the winning value of 5. And then we can specify our while loop, because we want to keep on doing this, rolling our dice until we hit the winning value. So the general structure of a while loop again. And what are we going to do inside this loop? That's keep on throwing the dice. So I just copy and paste it inside the while loop, because this is the thing we want to keep on continuing. And as always, I keep on repeating this. If we specify something within the while loop, mostly, we want to specify the value of that variable also outside the while loop. So let's do that. I'll call it 0 for now. I'll come back to it later. Then we have to specify the input of the while loop. MATLAB needs to know, okay, what condition you want to be met before I start running this loop. Well, in words, that would be as long as the throw value is not the same as the winning value. So let's translate that sentence to MATLAB code. While the value of throw is not equal to, which is this tilde and equal sign. This is explained in either the in-class explanation of week 2 or week 1. If you forgot about this, and all the others as smaller than, bigger than, etc., have a look at those challenges again. Is not equal to winning value, I want you to go into the loop. That's what this is saying. So is this condition being met the first time we encounter line 56? Yes, because the value of throw is 0 the first time, and that doesn't equal 5. Then we start on throwing our dice. And I expect when I randomly throw the number of 5, the winning value, it will go up and it will compare throw to the winning value, and suddenly throw is 5, and then it's equal to winning value, and this condition is not being met anymore, and the while loop is stopped. So let's check. Let me run this. All right, it runs, and the value of throw should be now 5, right? Because otherwise the while loop would have not stopped. And indeed, it's 5. All right, that's first part of this assignment. But there was an addition. We want to print the number of throws needed. So let's think about that a little bit. We want to actually kind of store the number of iterations this while loop is taking, right? Well, then it's again the same thing. We need to keep track of the iteration. Let's call it the counter. And this counter is going to be updated within the while loop. And each time you run through this while loop, it's updated with 1. And as always, if we specify this variable within the while loop, we need to also specify it outside the while loop. And let's do that here. And the first time the counter should be 0. So the value of the counter is going to be the number of throws up to the moment we reach our winning value. So let's run this and immediately provide the output. So I'll print the counter and throw. The throw will be always 5 because otherwise the while loop wouldn't stop. So let's check the output. This time the counter was 4, so I needed I needed to roll the dice 4 times before I hit the value 5. This time I needed 6 times. This time only 1 time, though I was very lucky, well, etc. Right? So again, we're going to specify this inside the function. Well, that routine should become clear now. We open a new file called function. Everything is provided here. We remove the default information, copy and paste what our own code and paste it within our function. Then we're going to name our function, which we call this case dice game. It's a little game with dices. Then I save it. Again, I get the default exactly the same as my function name. So dice game, save it. Then we think about the output arguments. Well, in this case, we only have yet one output counter. So we can remove the brackets again and call this one counter because we are interested in the outcome. Again, also we have only one input argument. And in this case, that will be the winning value. So we want to play this, being able to play this game for different winning values, not only for the winning value of 5. So we can keep the rest of the code exactly the same. Then we go back to our main script. We can call our function, which is specified here. So I'm only clicking this for clarification, right? I don't need to click this to use being able to use the function. So then we have dice game. And the winning value was 5 in our case. So let's do that. And let's run the code. And it provides you with the output of the number of times you needed to roll the dice, which is 1 in this case. So let's do a few: 4, 5, 1, 6. Okay, cool. So that's working, and we can use different winning values. So let's say, oh, it would be not possible because I have a 6-sided dice. Let's say I want to throw the winning value is 3, and it's still running. So actually, I didn't mention that with the assignment 1, but this is why you make use of functions, that you can generalize over different input values. So if I did not had this function, and I want to use another starting value, a winning value, so 3 instead of 5, I would have needed to rewrite the whole piece of code with a different winning value, which is super inefficient, right? And this makes it very powerful. I can use any winning value and it still works. So the goal of making function is that you can use them to generalize over different pieces of your code. So let's go to a little extension of this assignment, which even more demonstrates why functions are so cool and powerful. Let's extend this assignment a little. Now I would like to be able to specify the number of sides that the dice has. Additionally, I would like to implement that a player loses a bet when the lucky number has not yet been thrown after a number of tries. So let's focus on the first part of this question. So now we implemented the code that it's always rolling with a 6-sided dice. But imagine that I want to do this game with an 8-sided dice or a 4-sided dice. So let's go to the function. Where did we specify the number of sides of the dice? Well, we kind of hand coded it here, right? With 6. Well, because then we randomly draw an integer between 1 and 6. But now I want to do, if I want to do that for 3, for example, I can change this value. So to be able to specify this file outside this function script, so in our main script, we need to add an input argument. So let's do that. And I'll call it the number of sides of the dice. And instead of this hand-coded value, I'll simply replace that with the variable name. I save it, go back to my main script. And now I'm going to run my function again. So let's just first run the previous line of code we had. I'll receive an error. Why? Because I did not specify enough input arguments, because I just specified an extra input argument, and in this case we need 2. So with a 6-sided dice, that would have been 6. Let's evaluate that. And then we get the number of times you need to roll the dice. But now I can also say, like, okay, let's do it with an 8-sided dice. 4. Or let's do this with a 5-sided dice. 1. Or let's do this with a 12-sided dice. And probably this time the number of counts needed to get the winning value is a bit bigger, because your chances are decreasing with the number of sides of the dice. Of course, it's 7 in this case. It's even 36 in this case. See how easily a powerful function can be. We can change now even the number of sides and our winning value. And then the second part of our extension, I think of this assignment a little bit as a dice game. So it would be nice if the function, if there's a game element into this. And the game element is here that a player picks a winning value, but we can only throw the dice a maximum number of times. And if then that value has not been come up yet, then the player loses. So let's go back to our function, the dice game. And let me first think of, okay, we want to return a function, a value, displaying that the player, giving the player some information about the outcome of his game. Well, when the while loop is being quitted like this, we did not put yet a number of maximum throws, it will always win. So as we implemented the function now, the player is always winning, right? Because we didn't put a maximum limit of number of times that somebody can throw the dice. So in this case, you can, at the end of the output, you can say, you won the bet. Then I save it. So I didn't change anything actually. I just, when you run this code, the function will display this little sentence. So let's try that. And as you can see, it's displaying what I've just specified, you won the bet, even if you did 20 numbers of rolling the dice. And now I want to specify a maximum limit on this. Therefore, we need an extra information inside this function, and that's specified by the user of this function. So number of max, or let's call it the limit. So let's say that limit will be 10. So after, up to the moment that you've been throwing more than 10 times, you're losing if you didn't get your winning value yet. And here was again a keyword in my explanation. It's like if you did not yet reach your winning value. So we need to do something with if. Well, what's keeping track of the number of rolling dice we did? That's the variable counter, right? And as I said, the keyword was here if. So then we go back to the if-else statements that we have been using in the challenges of week 2. If you don't know anymore how to do it, have a look at those challenges again, or the tutorial, the previous video tutorial. But this is general, specific general outline of an if structure. If something is true, we're going to execute the line of code inside this if statement. So let's say if the value of counter reaches the limit, right, equals the limit, we want to stop this game. So we want to break out this loop. Why? Because it doesn't make sense to throw any dice anymore because the player already lost. So then we say break. So we're already getting a bit closer. In this case, we specified limit as 10. So if that reaches 10, we stop the game. And also let's display some information. You lost the bet. Best bet. And as an example, I put this here to 10, but of course this must be the input value. So we can remove this line of code. All right. Let's save this. So what's going to happen? The counter keeps track of the number of iterations of the while loop. If this number reaches the limit, the while loop is quitted and you're provided with the information that you lost the bet. Okay, let's see how that works. So again, we can use dice game, which I already specified here. When I'm going to run this, I'll get an error because it needs an extra input argument, the limit. So I set that with 10. Let's run this. All right. Okay, this is interesting. I did this on purpose, actually. So what we first see is our answer. That means it's 10. So the count has been 10. And then the while loop quitted. Because otherwise it wouldn't not exactly equal the limit. And indeed, correctly, the information that's displayed is you lost the bet. So apparently, we indeed came here. You provided information, you lost the bet, and then we got out the while loop. But although we break out this while loop, let me make this line of while. Break out this while loop, we keep on continuing the rest of the line. So this line 14 is still being executed because the function is going to execute all its lines. So although you break out this while loop, you still continue running line 13, which is stated nothing, but also line 14. So there it specifies you won the bet, which is confusing because we now provide double and inconsistent information. So we need to think how we can solve this. Well, instead of displaying you won the bet, we're going to display the outcome, which is a variable that's not yet known by MATLAB. So we will specify here. Again, we just specify in a starting value before we start a loop. And the starting value in this case is you won the bet. And then you have the outcome. So when we start the game, somebody is winning, basically. Then we always go into the loop and we're going to do our routine. And if we reach the limit, we're going to override, so update again the variable, but this time, indeed, if this is true, somebody lost the bet. And in this way, we solved that we had printed both options. So in general, we only print one of those outcomes, whether player won or lost, depending whether you arrive into this if statement. Yes, so let's check that. I'll just run this. Okay, I see specified here, you won the bet with the answer equals to 3, which makes sense because the number of times I rolled the dice is only 3, and I specified the maximum limit on 10. So in this case, I won. So let's try another one, see if we... So again, I won the bet because I only needed 2 times. Again, I'm very lucky because I only needed 1 time. But here, I lost the bet because I already reached the maximum limit, right? Which is correct, output 10. Well, yeah, so I'm winning quite often, but now I'm losing again. So this is working. I want to advise you, this kind of extensions, you can come up easily yourself. When you work on this kind of games and you have time left, you can think of a million ways of extending your little function, and it's a very good exercise. So what I did here is just something I came up with, but I can even think of other extensions, making them a bit more sophisticated. For example, my lucky number, my winning value can be never bigger than the sides of dice, right? Because then I will get in an impossible situation. And at the moment, my function is ignoring that. But you can extend your function by returning a value back and telling the person that specifies the starting value, like, hey, this is impossible because your winning value is bigger than the maximum numbers that the dice has. So try to challenge yourself in these small ways if you have time left. All right, then we arrive at question 3. Where you have to calculate the mean. And this question is very similar to the factorial question. And actually, with my elaborate explanation, I think now, so I introduced first the general structure of the for loop. Then I gave you a little example of how to build a for loop to make your own summing function. Then we explained the factorial function and then the dice game. I think this is a challenge that I leave open for you. I think it's good to do this on your own and see whether you can make it using the logic of the previous assignments. The same counts for 3b, that's the breakpoints, which is all explained in the previous video tutorial by Mark. So have a look what that's telling you and how you can use it. Yeah, I still want to talk about cell arrays, which is a new structure within MATLAB. Why? Because we encountered this structure, data structure, in our next week assignment of now upcoming Thursday. We will get into the cell arrays. So I want to just notify you of it. So far, we know this. We have been using a lot this type of data structure, which is called a vector. But as we already explained to you in week 1 of this course, is that strings and vectors are tricky. So when we want to have a vector with the name of our friends, and each name defines a new element, if we run this, we, instead of getting 3 separate elements, we get 1 element. So the strings within a vector are automatically concatenated. That's something we don't want. And for this, we can use cell arrays. And cell arrays are cells within MATLAB, and you can put any type of data. So with vectors, it's limited to scalars or values. But with cell arrays, you can also use strings. And how can you use these cell arrays? That's by using these curly brackets. So let's evaluate this. It's exactly the same as the vector, but instead of the squared brackets, we use the curly brackets now. And now we obtain a vector with 3 elements, or I should not say vector. We obtain a cell array with 3 cells in there. And it works the same if we want to get access to the Anna, the second element of our cell array. We can use the same logic again. So as we did with vectors, we can specify element 2, but in this case, and then we can just exit indeed that element. A more powerful thing of cell arrays is that we can even combine different data types. So I can even use strings and then use a scalar, and even then the output of our cell array is organized, and then we can get access to, let's say, the second element, and actually to get retrieve the elements of a cell array, I so far used these round brackets, but instead you should be using curly brackets, because then you get really the value. You see the difference here, right? So that makes it very easy to work with. So even this extension, we can even use a vector within as an element with 2 other string elements, and then even this type of data structure will still work, and then we can retrieve the second element, friends, curly bracket 2. So use the curly brackets in this case, and then I get my vector. If I would use the round brackets, I would get only the 1 times by 3, so I don't get really access to the vector. So if you work with cell arrays, use also the curly brackets to get access to your elements. Overall in the course, we're going to mainly work with vectors because they are easier to deal with and to do calculations with and mathematical operations, which is the goal of this course. But at the moment you arrive at challenges in which you use strings, you should think of cell arrays. And the way of dealing with them or to specify them works basically the same as vectors, but instead of the square brackets, use the curly brackets. All right, that was everything I want to say for now. And so everything I've been explaining will also come back to the challenge of upcoming Thursday, challenge 4, in which you're going to continue working on structuring for loops, while loops, if else statements, to get more experience with that. And then I will repeat myself for the last time. Whenever you get a challenge by which you have to use a for loop, you always start first specifying, defining the variable outside this for loop. Then you type in the structure of the for loop, and within that for loop, you're going to define that variable you want to update. Yes? All right. Then I'm going to stop this video.